the function f is defined by f of x is equal to e3x over 4x squared plus k, where k is a positive constant. We need to show that f dash of x, so dy dx, the differentiated function, is 12x squared minus 8x plus 3k times another function g of x. So we're differentiating. It's in the form u over v. So it is the quotient rule. And the quotient rule says dy dx is v du dx minus u dv dx over v squared. There's another version of this with f of x and g of x in the formula book. So we're going to have u and v. U is our numerator. So u is e3x. And v is our denominator, 4x squared plus k. So we're going to differentiate both of these. So du dx. When we differentiate e, it stays the same, but we times by the power differentiated. So it's going to be 3e 3x and 4x squared plus k differentiated. So times by the power, take one off the power, and k is a positive constant, so that will disappear. So now we just substitute them into our formula. So v du dx. So it's actually f dash of x, not dy dx. I'm going to write f dash x is v du dx. So these two times together, 3e 3x times 4x squared plus k minus u dv dx, 8x times e3x all over v squared, 4x squared plus k squared. We need to get it into this form so we can expand the top line, and that will hopefully give us something close. So 3x times 4x squared, 3 4s are 12, and then we've got 12x squared e3x. 3x times k will be 3k e3x. And we've got minus 8x e3x. And that's over 4x squared plus k squared. So we're quite close. We've got the 12x squared minus 8x plus 3k. We need to factorize out e3x. So f dash of x. If they're factorizing out e3x, just looking at our top line there. So e3x on the outside, we can have 12x squared minus 8x plus 3k all over 4x squared plus k squared. So we've got it in the right form. So g of x, we can just say g of x is e3x over 4x squared plus k squared. So it's in the right form. It's 12x squared minus 8x plus 3k times by another function. So that's done. Part B, given that the curve has at least one stationary point. So stationary points are where the gradient is 0. So the gradient's at 0 at least one point. So where is it 0? Let's start with that. So stationary point is where f dash x equals 0. So that's e3x times 12x squared minus 8x plus 3k over 4x squared plus k squared is equal to 0. If we want to find the stationary point, what could make this 0? So times both sides by 4x squared plus k squared. The denominator can't be denominator is no good to us. We're not interested in it, so it can disappear. E3x can't give us a 0. So this whole function g of x can't give us a 0. It can't equal 0. So it must be a stationary point where 12x squared minus 8x plus 3k is equal to 0. And it's a quadratic. So we're told that it has at least one stationary point. So this quadratic must have at least one point where it's equal to 0. So it's either got one solution or two solutions. And that's the discriminant. It's where b squared minus 4ac is bigger or equal to 0. So to have one stationary point, it's equal to 0. Have two stationary points, it would be bigger than 0. So b squared minus 4ac must be bigger or equal to 0. So we can say a is 12, b is negative 8, c is 3k, and just substitute them in. So we are going to have negative 8 squared minus 4 times 12 times 3k is bigger or equal to 0. So that is 64 minus, what's 4? That's 144. 4 times 12 times 3, 144. So minus 144k is bigger or equal to 0. 64 is bigger or equal to 144k. So k is less than or equal to 64 over 144. Let's simplify that. 4/9. So that tells us that k is less than or equal to 4/9. Now we've also been told in the question, so to give the full values of x, k has got to be bigger than 0, but less than or equal to 4/9.